In this example, we're asked to find a step function, and this is on a closed interval 0 to 5. It has two properties. We know that the integral from 0 to 2 of this function has the area of 5, and that the integral from 0 to 5 of this function has area 2. So notice it decreases as we get further along. If you're asked to create something like this, a step function, one of the tools that we're going to use is we're actually going to draw a picture, and we're going to use that to kind of figure out what we should be looking at here. So notice we want to go all the way out to 5. So I'm going to put 5 pips on here. And we're going to go a little bit up and a little bit down. All right, so let's start off with the first bit of this. We want our function on the scale from 0 to 2, so that's going to be up to here. We want that to have an area of 5. And this has to be a step function of sorts. So our function in particular has to look kind of like a staircase. It's got to have bits to it, right? So we want it to have stairs. One of our stairs at this point, if we're going to have 0 to 2, let's split our function up at 1. We're going to make this very nice and easy. Let's give one of these a height of 3. We're going to make two different rectangles. Our first rectangle, we're going to give a height 3. And I'm going to make a closed circle at x is equal to 0 and an open circle at 3. Now you'll notice that if we make a rectangle out of this, our rectangle is equal to area 3 because it has height 3 and width 1. Next thing we want is we also want a rectangle of area 2. And notice these all have to be rectangles because we're talking about a step function. And so that makes it a little bit easier, and that's how we knew how to break up our situation for the first bit here. Right? Now our second rectangle has area 2 because it has height 2 and width 1. So writing that out as a function, f of x is equal to 3 if x is between 0, there we go, x and 1, and I'm going to give it, we're going to do an underline over the inequality for 0 and nothing under 1 because we want that to be an open spot there. And 2 if x is less than or equal to 1, and let's just make this simple. We're going to have an open circle at 2 as well. All right, so that gives us our area of 5. 3 plus 2 gives us 5. For the next bit, now we need to think about our second integral here. When we go to 0 to 5, we want to have the area of 2. Right now, we have the area of 5, which means we need 3 less. So we're going to have to get area underneath the curve in order to get area 2 when we integrate from 0 to 5. To do that, notice if we go to -1, let's see, I just want to point out here from 2 to 5, that has width 3. So if we can make a rectangle here of area -3, we're going to be golden. So let's start here. We'll go to 5. This is going to be a closed circle again because we actually do want a closed interval. And this rectangle here has area -3 because it has width 3 and height 1, but it's underneath the y or the x-axis. So it's going to be so there's our function there. So there's what our step function is going to look like. And you know, you can play around with it. This isn't the only solution, but it's the most straightforward solution, something similar to this for this problem. Have fun creating those examples.